Alright, so what we're going to do in this video is we're going to go over how to find the roots of a complex number. The cube roots, the square roots, the fourth roots, the fifth roots, whatever they may be. So we know every non-zero complex number has exactly n distinct complex nth roots. So we're going to take the theorem that we talked about, De Moivre's theorem from the last video, and we're going to extend it to help us find all our nth roots of a complex number. So the nth root theorem says if n is a positive integer, r is a positive real number, that's the length of the hypotenuse of my right triangle that we find, and theta is in degrees, then the non-zero complex number in trig form has exactly n distinct nth roots, and we can find them by using this. We're going to start by using our compact form. What we're going to do is we're going to take the nth root of r, and then we're going to do theta plus however many degrees to find all of our other roots. And if we're using radians, remember we're not going to use 360, we would use 2 pi. And k tells us how many added times we're going to find our root. It'll make more sense here right now. So let's find the 3 cubed roots of -8. Alrighty, now normally what happens is I say find the cube root of -8 and you tell me it's -2. Alrighty, if you were to put that into your calculator right now, and I asked you to find the third root of -8, your calculator would tell you it's -2. Alright, that's true, but what we also know is there are 2 more roots that go with this, because there are 3 cubed roots that go with this value. And our job, what we're going to do right now, is find those other roots. Well, the first thing we're going to do is we need to write this value in trig form. Oh, let me get a pen going on. We're going to write this in trig form. So when I'm looking at my number, we know x is -8, y is 0. So that's going to let us find r. R is going to be the square root of -8 squared plus 0 squared, which is a positive 8. And then we're going to find theta. Theta is the inverse tangent of y over x, and x is -8. Sorry, my writing's a bit sloppy. So when well, this is actually even easier if you look on your grid. If x is -8 and y is 0, here's my complex vector right there. So we know theta is going to be 180. Because when is y 0? Y is 0 at 180 and 360. All right, now I have all the parts I need to write this in trig form. So in trig form, we are going to say 8 times cis of 180. Boom. Well, but since we're finding the nth root of this is what z equals. We want to find the cube root of z. So to do that, we are going to take the cube root of r, which is 8, and we're going to say multiply that by cis of 180 plus 360k, all divided by 3, because that's my root. So we're going to have 2 times cis, 180 divided by 3 is 60 plus 120k. And I like to say we're going to do that. Boom. All right, so that's how we're going to find it. Now, let's find them. We want to find the first three, the three cubed roots. It's a cube root, so we're going to find three values. What we are going to do is we are going to make k equal 0, we're going to make k equal 1, and we're going to make k equal 2. So when k is 0, this is just a 60. Well, at 60, so the cosine of 60, is 1/2 plus I sine 60, that's going to be I radical 3 over 2. So then 2 times, to distribute the 2, I am going to get 1 plus I radical 3. If k is 1, we're going to do 2 times, I don't know why I keep writing an S first, cis of 60 plus 120 times 1 is 120. So we're going to do 2, 180. Well, there's my 180, so we're going to do 2 times negative 1 plus 0. Distribute, 2 times negative 1 is negative 2. Boom, that's the negative 2 we got at the very beginning. And this is one of the imaginary roots. Now this should give me another imaginary root, because imaginary roots always travel in pairs, if you remember. So we're going to do 2 times cosine I sine of 60 plus 120 times 2 is 240. So we're going to do 2 cosine I sine of 300. Well, 300 is has a reference angle coming down of 60. So that's going to be positive 1/2 minus I radical 3 over 2. So 1 minus I radical 3. Boom. And those are the three roots for when we find the cube root of negative 8. I think it's kind of cool. Alrighty, so what we're going to do is when we get back together with each other in class, we're going to do our next example, example 5, as a group. You know what? If you want, give it a shot. Remember to make it a trig form first, and then go from there. I hope everybody's well, and I will see you when I see you.